करनी है. So you have to find the empirical formula. How do you find the empirical formula? Divide uh, by the AR, which is going to be 12 over here, and the other one is HK1 hai, and oxygen is 16, right? Can you even do this? What's 64.86 divided by 12? क्या value होगी?
5.41.
Okay, so carbon is coming out to be 5.41. This is 13.5, I think. And what's 21.64 divided by 16?
1.35.
Okay, this is 1.35. फिर divide by the smallest कर लो ताकि whole number ratio आ जाए. Hopefully you will get a whole number ratio. So divide everything by 1.35. So oxygen जो है, that's 1. What is 13.5 divided by 1.35? Okay, 13.5 divided by
10.
that's about 10 आ रहा है. And what's 5.41 divided by 1.35? 5 point.
4.
Okay, that's coming out to be 4. So that's coming out to be 4. इसका मतलब है C4, H is 10, and you have O, which is 1. As the next part is, he's saying that the molecular formula is the same. The empirical formula and the molecular formula is the same. And this is the formula of the compound. And he's saying B is found to be chiral. This is B. And they're saying B is found to be chiral. Draw a displayed formula of the two optical isomers of this compound indicating with an asterisk the chiral carbon atom. Okay? So C4H10O1. Pehle though, let's try and figure out that you can draw a number of isomers with that formula. So here's one. If I add OH, because there is an O, so let's see do I get 10 hydrogens or not? Okay, that's my first guess. So I am getting 10 hydrogens. Okay, so that means this is the form. This is probably one of the isomers that I've drawn. But is this the isomer that he's looking for? क्योंकि उसने कहा B is found to be chiral. Is this molecule chiral or not?
No.
ठीक है, it's
No,
not.
sir.
Because you need a carbon atom that is bonded to 4 different groups. So for that, what I can do is I can to make this
It's a
molecule. ठीक है, OH की position change कर दो, OH को कहीं और ले जाओ. So bring the OH over here and the H over here. Now if you look at this carbon atom, then it is actually chiral because it's bonded to 4 different. It's bonded to 4 different groups. So now it's chiral, and he's asking कि उसके ना दोनों optical isomers को draw करो. So you can do that. It's going to be carbon. टेट्राहेड्रल बनाओ वो जो chiral carbon atom है, ठीक है. So and he's asking for इस चीज का ख्याल रखना है, displayed formula. If he says displayed, then you're bound to draw every single bond. So it's going to be CH3 right side पे, ठीक है, that's CH3. Top पे H, bottom पे OH. So there's H, O और H का भी bond show करना है. और यहाँ पे there's 2 C's, CH2, and there is CH3. और फिर इसकी mirrored version would be exactly the opposite. उसको left to right literally invert कर दो कि the dotted bond would be over here. This is the wedge shaped bond, or CH2 CH3 was on the left, now it's on the right. H top पे था, वो top पे ही रहेगा. OH would start pointing in this direction, and the CH3 would be over here. So that's your mirrored version. That's the other isomer. उसने कहा था star भी draw करो, जो भी है ये. So that's basically your molecule. Clear है सारों को? रिदा, हिबा, आबा, बाज़गा? Clear है?
Yes, sir.
Yes, sir.
So the next part is कि you're being asked the 3 other structural isomers of B which are not chiral but which contain the same functional group as B. In the boxes below, draw the structural formula of these isomers. उसने 3 कह दिए. एक तो मैं draw किया था, that was अच्छा मॉलिक्यूल को ना अगर आप इफ यू डोंट इंक्लूड द हाइड्रोजन्स तो थोड़ा आसान होता है आइसोमर्स बनाना. अच्छा वन ऑफ देम हाइड्रोजन्स मैं बाद में ले आऊंगा ठीक है. वन ऑफ देम इज दिस वन कि OH इज एट द एंड. और क्या हो सकता है क्योंकि one of them we've already made the OH on the second carbon atom. So what I can now do is I can change the branch. तीनों carbon atoms को line चारों carbon atoms को line में ना रखो. One of them is over here and the OH is still at the end. और इसकी एक और version होगी which is going to be three carbon atoms and the OH is in the middle. ठीक है so that's ठीक है. तो I think this ये last वाला basically आप कह रहे थे. And रिमेंबर जब वो स्ट्रक्चरल फॉर्मूला कहते हैं ना तो वो फिर जनरल बात कर रहा होता है. रिमेंबर स्ट्रक्चरल फॉर्मूला के अंदर ना यू कैन गेट कंडेंस वर्जन लिख सकते हो, स्केलेटल फॉर्मूला भी लिख सकते हो, फुली डिस्प्लेड भी लिख सकते हो. Any formula that shows structural form that shows the structure of a molecule that is the structural formula. तो but
Sir, OH को हम can we write the OH on this branched carbon atom?
it would be the same thing कि मतलब OH को इधर लगाओ it's the
जी
same thing.
जी
मतलब वो उसी मॉलिक्यूल को रोटेट किया हुआ है.
नहीं मतलब
ये
isn't this carbon? जी
ये वाला OH की बात कर रहे हो ना कि तुम कह रहे हो इसको इधर
जी
लगा
जी
दें,
जी
राइट?
exactly.
तो मैं वो कह
हाँ
रहा हूँ वही चीज होगी, इसी को रोटेट कर दो. इट्स गोइंग टू बी द सेम थिंग.
हाँ,
और मतलब इसी OH को अगर इधर लगा दो इट्स गोइंग टू बी द सेम थिंग. ठीक है.
ठीक alright.
अच्छा बाकी H पूरे कर लो. देयर वुड बी 3 2 H's विद दिस 2 विद दिस 2 विद दिस. इसका तीन होंगे. तीन बॉन्ड्स बने हुए हैं. 1H दिस वुड हैव 2 H's, दिस विल हैव 3 H's एंड दिस विल हैव 3 3 और वो बीच वाला कार्बन उसके बॉन्ड्स पूरे हैं. ठीक है. सो यू हैव योर 3 अदर आइसोमर्स. अच्छा नेक्स्ट वन. ये हमने किया था कल कि नहीं किया था दिस क्वेश्चन. आई थिंक वी डिडंट डू दिस. सो द क्वेश्चन इज कि एस्ट्रोनॉमर्स यूजिंग मॉडर्न टेलीस्कोप्स ऑफ वेरियस टाइप्स, जो भी कहानी लिखी है वैसी इधर आ जाते हैं. मेन जो वो कह रहा है कि दिस दिस मॉलिक्यूल दैट्स हाइड्रोक्सी एथेनॉल. वो कह रहा है कि हाइड्रोक्सी एथेनॉल जो है ना दैट कंटेन्स टू फंक्शनल ग्रुप्स. व्हाट आर द टू फंक्शनल ग्रुप्स इन दिस मॉलिक्यूल? ठीक है.
Aldehyde and hydroxide मतलब alcohol.
ठीक है. सो इट्स एन अल्कोहल फंक्शनल ग्रुप एंड एल्डिहाइड. अच्छा रिमेंबर इस तरह का क्वेश्चन उसने इसलिए दिया कि आपको पता होना चाहिए कि एल्डिहाइड में ना जो H और O की जो तरतीब होती है वो उल्टी होती है व्हेन यू कंडेंस इट. मतलब O is with the carbon atom, H is on the outside, that's an alcohol. This one over here is an aldehyde. जब CHO बन जाता है ना C के साथ H लगाते हो just to differentiate between the two. अच्छा anyways, now he's saying कि part 2 के अंदर that for each functional group identify a reagent that will react with this group and not react with the other functional group. In each case, describe what would be observed when this reaction is carried out. So basically वो कह रहे हैं कि think of a reagent जो इसके साथ रिएक्ट करे अल्कोहल के साथ, दूसरे के साथ रिएक्ट ना करे, और फिर दूसरे के लिए भी think of a reagent that would react with the aldehyde and not with the alcohol. पहले ये वाला काम करते हैं कि एल्डिहाइड के साथ रिएक्ट ना करे, अल्कोहल के साथ रिएक्ट करे. तो what could be that reagent? नहीं तहा आइडोफोम टेस्ट जो है ना that's not possible कि मैं वो पहले अल्कोहल वाला खोल लूं. वो आइडोफोम टेस्ट भी मैं क्लियर कर दूं कि आइडोफोम टेस्ट जो है that's not going to be positive for this. एक सेकंड है ना ये खुल जाए. नहीं ये तो अल्कीन वाला खुल गया. अल्कोहल वाला क्या है? ये वाला है. जस्ट अ सेकंड ये बोर्ड खुल गया. अच्छा, सो अल्कोहल्स, अल्कोहल्स बने थे फर्मेंटेशन से, और 1 सेकेंड, ठीक है, एन मेटल, ठीक है, था एग्जैक्टली वही। और भी चीजें, बट एन इज वन ऑफ देम। अच्छा, ऑक्सीडेशन नहीं कर सकते बिकॉज एल्डिहाइड्स गेट ऑक्साइज्ड एंड अल्कोहल्स आल्सो गेट ऑक्साइज्ड। सो ऑक्सीडेशन वाला जो भी रिएजेंट होगा वो तो दोनों के साथ रिएक्ट करेगा। एल्डिहाइड्स ऑक्साइड होकर कार्बोक्सिलिक एसिड बना देंगे, एंड योर मॉलिक्यूल इज अ प्राइमरी अल्कोहल। इफ यू लुक केयरफुली, okay, this one is a primary alcohol, it's at the end of the chain, that's a primary alcohol. तो दोनों ही रिएक्ट करेंगे, so that's not going to happen. सेकेंडरी अल्कोहल तो है ही नहीं। uh, अच्छा, वो किधर है? अल्कोहल्स आर वीकली एसिडिक, ठीक है, तो ताहा ने कहा था कि सोडियम के साथ रिएक्ट करो, तो सोडियम के साथ एन अल्कोहल वुड रिएक्ट एंड इट वुड प्रोड्यूस हाइड्रोजन गैस। अल्कोहल्स ओनली रिएक्ट विद वेरी रिएक्टिव मेटल्स लाइक सोडियम, दैट्स वन। अच्छा, the other thing that could happen is alcohols form esters as well. तो एस्टर बना सकते हो कि बीच में कोई कार्बोक्सिलिक एसिड डाल दो और कॉन्सेंट्रेटेड सल्फ्यूरिक एसिड डाल दो, तो अल्कोहल जो है वो एस्टर बनाता है, तो दैट इज आल्सो अ पॉसिबिलिटी। तो दो पॉसिबिलिटीज है। सो गोइंग बैक टू द क्वेश्चन, सोडियम वाला काम आसान है। तो फंक्शनल ग्रुप 1 जो है ना, जो हमारा अल्कोहल था, अच्छा, जो हमारा अल्कोहल था, ठीक है, तो उसके साथ हम सोडियम रख लेते हैं। रिएजेंट और ऑब्जर्वेशन क्या होगी? देयर वुड बी एफर्वेसेंस, H2 गैस, बबल्स।
Sir, won't sodium also react with the acid?
एसिड किधर है?
मतलब नहीं, this sorry, ये aldehyde.
एल्डिहाइड के साथ कोई रिएक्शन नहीं है। एल्डिहाइड तो एसिडिक ही नहीं है ना इन द फर्स्ट प्लेस, ठीक है। तो अ, वो मैं कह रहा था कि कार्बोक्सिलिक एसिड डालोगे ना, तो अल्कोहल जो होता है ना वो एस्टर भी बनाता है कार्बोक्सिलिक एसिड के साथ, सो दैट इज आल्सो अ पॉसिबिलिटी। अच्छा, अब उल्टा कर लो, फंक्शनल ग्रुप 2, मतलब यू वांट द एल्डिहाइड टू रिएक्ट बट यू डोंट वांट द अल्कोहल टू रिएक्ट। अब क्या करोगे? ठीक है, एल्डिहाइड का टेस्ट मतलब बहुत सारे हो सकते हैं इसमें, ठीक है। दे कुड बी टॉलरेंस, दे कुड बी फेलिंग, मतलब ये उसी के अंदर था, ये जो बोर्ड था हमारा कि ऑक्सीडेशन के अंदर, कहाँ गया हमारा ऑक्सीडेशन वाला, दिस वन। सो टॉलरेंस एंड फेलिंग, दे वुड ऑक्साइड एन एल्डिहाइड इनटू अ कार्बोक्सिलिक एसिड, ठीक है, दे गोइंग टू डू दैट। टॉलरेंस और फेलिंग जो है वो प्राइमरी अल्कोहल के साथ रिएक्ट नहीं करते, और टॉलरेंस के साथ क्या होगा? इट्स गोइंग टू बी अ सिल्वर मिरर, और फेलिंग के साथ इट्स गोइंग टू बी अ रेड प्रेसिपिटेट दैट्स गोइंग टू बी प्रोड्यूस्ड। और चीजें भी हो सकती हैं, एल्डिहाइड्स के और बड़े रिएक्शंस है। एल्डिहाइड में अगर जाओ ना, तो एल्डिहाइड 2,4-DNPH के साथ भी रिएक्ट करता है, जो एल्डिहाइड और कीटोन्स दोनों को आइडेंटिफाई करता है, व्हिच इज दिस वन, कि you would get any carbonyl compound, aldehyde or ketone, would react with 2,4-DNPH to form an orange precipitate. So that's also a possibility. So you have plenty of options. सारे ही लिख देते हैं कि टॉलरेंस के साथ the aldehyde would form silver mirror. That's the observation. Filling के साथ it would give a red precipitate. अच्छा, और फिर एक आखिरी वो कर देते हैं कि which is going to be 2,4-DNPH. तो 2,4-DNPH में the aldehyde would give an orange precipitate. और वो भी डिस्कस कर लेते हैं कि किसी वो ताहा ने आयोडोफॉर्म कहा था, सो लेट मी जस्ट क्विकली गो थ्रू आयोडोफॉर्म, कि आयोडोफॉर्म कौन सा टेस्ट होता था। ये आयोडोफॉर्म जो होता था ना, वो उसके लिए, सो आयोडोफॉर्म इज नॉट गोइंग टू बी द करेक्ट ऑप्शन। आयोडोफॉर्म टेस्ट जो होता था ना, एल्कलाइन एक्वस आयोडीन, NaOH एल्कली डाली हुई थी और आयोडीन, that was a test for identifying a very specific type of structure, कि या तो मिथाइल हो सीरियल बॉन्ड O के साथ, या मिथाइल हो COH के साथ और H के साथ, ये दोनों में से कोई एक स्ट्रक्चर होना चाहिए ताकि मिथाइल टूट के CHI3 का येलो प्रेसिपिटेट बनाए। only then would the iodoform test be positive. Okay, this exact ये जो yellow के अंदर structure बना हुआ है ना, this exact structure has to be, it has to be there. तो नहीं, not just ethanol. हाँ ठीक है, प्राइमरी अल्कोहल की बात करें तो ठीक है एथेनॉल होगा, लेकिन किसी भी अल्कोहल में ना ये स्ट्रक्चर होगा ना, तो इट्स गोइंग टू गिव अ पॉजिटिव टेस्ट. ऑल्दो सिर्फ जो सिर्फ एथेनॉल होगा प्राइमरी अल्कोहल्स में जिसमें ये स्ट्रक्चर होगा. बट एनी अल्कोहल दैट हैज एग्जैक्टली दिस स्ट्रक्चर, दिस अरेंजमेंट. आर जो है वो कार्बन चेन है, ठीक है, इट कुड बी एनीथिंग, एच भी हो सकता है. तो ओनली देन इट्स गोइंग टू बी अ पॉजिटिव टेस्ट. अच्छा, सो इज दिस क्लियर?
Yes, sir.
अच्छा, नाउ किधर थे हम? अच्छा, एल्डिहाइड का टेस्ट हो गया, ठीक है. अच्छा, नाउ वी सेइंग गिव द स्केलेटल फार्मूला, ठीक है. बी वेरी केयरफुल कि कौन सा फार्मूला मांग रहा है. स्केलेटल फार्मूला ऑफ द ऑर्गेनिक प्रोडक्ट फॉर्म व्हेन हाइड्रोक्सी एथेनॉल इज, दिस इज अ रिड्यूसिंग एजेंट. तो रिड्यूसिंग एजेंट्स क्या करते थे? रिड्यूसिंग एजेंट्स करते थे कि आपका वही जो सारी चीजें ऑक्साइज हुई थी, एल्डिहाइड वगैरह, उनको वापस रिड्यूस कर देंगे, ठीक है. ये रिडक्शन वाला है कि रिवर्स कार्बोक्सिलिक एसिड वापस एल्डिहाइड में, एल्डिहाइड वापस प्राइमरी अल्कोहल में. तो आपका जो मॉलिक्यूल था दैट वाज दिस वन. अल्कोहल तो रिड्यूस होगा नहीं, क्योंकि वो तो एंड प्रोडक्ट है रिडक्शन का. ये जो एल्डिहाइड वाला पार्ट है ना, ये रिड्यूस हो जाएगा. आपने सिंपली क्या करना है, उसको OH में कन्वर्ट कर दो, ठीक है. तो उसको आप OH में कन्वर्ट कर दो. सो व्हाट यू आर बेसिकली गेटिंग इज यू गेटिंग अ डायोल. दोनों साइडों पे अल्कोहल आ गया. दैट्स इट. इब्रार बाजा, ये क्लियर है? आबा, इज दिस क्लियर?
Yes, sir. Clear.
अच्छा, दूसरा है कि वो कह रहे हैं ऑक्साइज कर दो. ऑक्साइज करोगे तो अभी हमने पढ़ा कि प्राइमरी अल्कोहल जो है वो किस में ऑक्साइज हो जाता है? कार्बोक्सिलिक एसिड में. और आपका जो एल्डिहाइड है वो भी ऑक्साइज किस में हो जाता है? कार्बोक्सिलिक एसिड के अंदर. सो यू विल गेट अ डाई इथेन डायोइक एसिड. दोनों साइडों में ना इट्स गोइंग टू फॉर्म अ कार्बोक्सिलिक एसिड. बोथ ऑफ देम वुड चेंज इनटू कार्बोक्सिलिक एसिड, ठीक है. तो नेक्स्ट पार्ट, नाउ दिस पार्ट इज कि अगर क्वेश्चन सारा पढ़ो तो ये कह रहे हैं कि there's a so it says कि there's a school and college laboratory and you have to make ये वो आपका मेरे ख्याल से this is your hydroxy ethanol. Now if this is your hydroxy ethanol and you have to convert it into this thing, now how would you convert this into this thing? And he's asking if figure out what X and Y are. Well, figure out the middle parts. Not only that, I think he's going to ask for the conditions for step 1, 2 and 3. Exactly, he's asking for the conditions as well. So the right side is not that difficult. This side is the aldehyde. You want to convert that into a carboxylic acid. That's not an issue. What you're going to do is you're going to oxidize it eventually. So the aldehyde would get oxidized into a carboxylic acid. But how do you get an amine over here on the left side? How do you convert an alcohol into an amine?
Nucleophilic substitution.
ठीक है, nucleophilic substitution. We did this in halogenoalkanes. ठीक है. We did not study NH2. NH2 is not in your course, but we did study products where amines were getting formed. So I think, not this one. नहीं, ये तो
Sir, I'm
बता.
not clear with ये nucleophilic substitution, electrophilic. Nucleophilic में ये होता है कि negative ions are being attracted to the carbocations और मतलब cations basically. ऐसा ही होता है ना?
किस पे? nucleophilic में? नहीं, I'll
जी
do that.
मतलब अच्छा.
As a first thing, halogenoalkanes, right? What we want is, where did you get NH2? This reaction, not this one. That if you have a halogenoalkane, halogenoalkanes have three nucleophilic substitution reactions. These are the nucleophiles: Cn minus one, OH minus one, and NH3. If you bring in the NH3, the NH3 will replace the Cl, and you will get an amine. I mean, this is what nucleophilic substitution is. As I brought nucleophilic substitution, where there's a nucleophile, it could be OH minus one, NH3, or Cn minus one. They have lone pairs. Nucleophiles always have lone pairs. Yeah, they have a pair of electrons which they're capable of donating. So nucleophiles are attracted to positive charge. Why is this carbon positive? Because it's attached to a halogen. Halogens are electronegative, so which makes the carbon partial positive. So that's what a nucleophile is. This is why it's called nucleophilic substitution. Ibrahim, is this clear?
Yes, sir.
This should be clear as well. There is no electrophilic substitution, at least in AS. Okay, so you're not going to be asked about, or there's a high probability you'll never be asked about electrophilic substitution in AS. A2 के अंदर है, not in AS. अच्छा, so your NH3 nucleophile is going to come in and it's going to push the Cl away. It will be attracted to the carbon and the Cl will get knocked out. But this thing happens with halogenoalkanes. So the first thing is we need a halogenoalkane to begin with. So the first thing is convert the alcohol into a halogenoalkane. How do you convert an alcohol into a halogenoalkane? That's also nucleophilic substitution, but get rid of the OH, and in its place you add Cl. So the conditions are PCl3 plus heat or SOCl2 plus heat. So you'll convert that into a halogenoalkane. So let's try doing that. So the first step is, okay, I'm going to do this over here. नीचे draw कर लेते हैं. I'm going to convert it into X. X would be CH2, and I'm going to bring a Cl over here. And the other side is the aldehyde side. I'm not going to touch the aldehyde first. So I've gotten a Cl instead of the OH. Okay, the OH is gone. So this is PCl3 plus heat. I said then I'm going to convert it into Y. Y would be that the CH2, don't touch the aldehyde side. The Cl is now replaced with NH2. So that means the Cl has been replaced by NH2. And for this, you need ethanolic. Because somebody did mention it. You need ethanolic NH3 plus reflux.
Sir, in step 1, if we are do not replaced OH with Cl, तो एक ही बात नहीं होती?
Yeah.
If we are not replaced OH with the Cl.
I mean, there's no
तो
reaction
एक ही
where the NH2 comes and directly replaces OH.
अच्छा, alright.
But nucleophilic substitution are reactions for halogenoalkanes, not for alcohols.
सही, ठीक है.
So you have to convert it into a halogenoalkane. So the last part is the oxidation part. Convert the aldehyde into carboxylic acid. So you could use K2Cr2O7 or any of the oxidizing agents. So why did I keep the oxidation part right at the end? Why did I do oxidation in step 1?
Because then alcohols would also get oxidized.
Okay, because I did not want the alcohol part to get oxidized. I wanted the alcohol part to be replaced by Cl, and then the Cl part to be replaced by NH2. So if I had done oxidation initially, so aldehyde would turn into a carboxylic acid, but the alcohol would also turn into a carboxylic acid. So that would be, then it would be difficult to actually convert that into NH2. So is this clear, Rida? Hiba, is this clear? Abba, is this clear? Now we've stated the reagents need step. So that's done as well. The next question is that there's butanene, and it's an important compound in the petrochemical industry. Some reactions of butanene are given below in each empty box. So you just have to. This is hydration. This is water getting added. So there's water getting added, and what you're just going to do is that the double bond H and OH will get added to it. But where does the H get added to? What was the Markovnikov's rule?
To the carbon which is bonded to most hydrogen atom.
Okay, so there's one hydrogen here and the two hydrogens. So the OH would be bonded over here, and the H would be bonded to the last one. So then, so that's it. So then there is a strong oxidation. That's hot concentrated KMnO4. What happens? The double bond is going to completely break. And if it breaks, it's going to give you this thing. At the end, it's going to give you a carbon with two hydrogens. What does that get converted into?
Acid.
This would get converted into carbon dioxide.
Ah, yes, sorry.
You get two hydrogens. And the other part, that's CH3, CH2, and CH double bond. So that's CH and double bond. So carbon with
So we'll
one,
get NG.
so that would be propanoic acid. अच्छा cold वाला cold के अंदर क्या होता था? That was mild oxidation. Diols were formed. That you would have four carbon atoms and OH groups will get added. The rest are all hydrogens. ठीक है, so that's going to be produced in the middle part. So then you have, now he's oxidizing it. So this one is a primary alcohol because it's bonded to one carbon chain. This one is a secondary alcohol. So what does primary alcohol get converted into? It gets converted into a carboxylic acid molecule, and the secondary alcohol would turn into a ketone, and the rest is CH2 and CH3. Okay, so remember, okay, this one over here is a secondary alcohol, and this one is a primary alcohol. Okay, is this clear?
Yes.
Yes.
So just 1 second. I said then you have the next question. Next question is compound T reacts with compound. You draw the displayed formula. T and U are reacting. So what's T? What's T? T is an alcohol, so it's an ester formation. T is an alcohol. It's butane-2-ol. This one is propanoic acid. So T and U are reacting together. So we're going to react them together, and we have to draw the displayed. Show every bond. So here's an alcohol, and the alcohol has an OH group over here. And the other one was a propanoic acid molecule. So what I'm going to do is I'm going to draw the propanoic acid molecule the other way so that the functional groups could face each other. The carboxylic acid loses its OH, the alcohol loses its H. So they would be gone in the middle and they would end up forming an ester. An ester would be formed as the two chains would join up. And the rest is you can add the hydrogens. Okay, you have to, it's a displayed formula, so draw every single bond. So these are your hydrogen atoms. So you can fill them up. Is this clear? Ester formation.
Yes, sir.
Yes, sir.
So then you have, now there's this other question on moles again. 1 second. So let's try and do this. So there's 0.24 grams of A. I mean, that's the first thing. And isn't it the same question? It looks like the same question. I think it's a different question. So A is completely oxidized, and A reacts with oxygen to produce carbon dioxide and H2O. Now he's given you 0.352 grams of carbon dioxide. So how do you find the mass of carbon in 0.352 grams of carbon dioxide? What you're going to do is find the percentage of carbon. How much carbon do you have in carbon dioxide? That's just 12, right? And what's the total mass of MR of carbon dioxide? That's 44. So you multiply by the percentage of carbon in carbon dioxide. What do you get?
27.3.
Did you multiply it by 0.352?
0.096.
कितने?
0.096.
0.96 grams. Achha,
Yes.
use this value to find the moles of carbon atoms. So you know the carbon atoms. Now you have to find the moles of carbon atoms, which is going to be 0.096 grams divided by 12. What do you get?
0.008.
Moles. Okay, so it's going to be 0.008. Achha, one mistake that even I'm making is make sure you use the right number of significant figures, because the question is using 3 significant figures, so you should also add 2 more zeros to make it 3. Everywhere you would see 3 significant figures being used. So use the minimum significant figures given in the question. And this should be 0.0960. And so then the mass of hydrogen in this thing, in water. What's the percentage of hydrogen in water? There are 2 hydrogens, right? In water. Water has a total mass of 18. So 2 out of 18, that's hydrogen. So if 0.144 grams of water is given, that would give you the mass of hydrogen, which is
0.016.
and you're being asked to calculate the moles of hydrogen atoms. So it would be 0.016 grams divided by hydrogen is 1. The AR is 1. So the moles would be the same, 0.016 moles.
Sir, isn't it saying कि hydrogen atoms तो दो लेंगे? Won't we take it as a 2?
तो हाइड्रोजन एटम कह रहे हैं ना,
Atoms क्या?
मतलब एटम्स ही होंगे ना, प्लूरल ही होगा ना, एक हाइड्रोजन एटम थोड़ी होगा.
Right.
मतलब एक तो कभी भी नहीं होगा ना, मतलब you get 0.016 moles is a huge quantity. It's a huge quantity of atoms, ठीक है. तो अच्छा, the end result is that you have this many carbon and this many hydrogen. Ratio क्या है इनका? 1:2 है, right? Okay, the number of hydrogen atoms in the formula should be double the number of carbon atoms, right? So now he's saying use your answers to calculate the mass of oxygen. Okay, now we have to calculate the mass of oxygen. So A is 0.240 grams. What was the mass of carbon that you had? The mass of carbon was over here, it was 0.096 grams. So that was 0.096 grams. What was the mass of hydrogen? That was also 0.016 grams, right? So this was carbon, this was hydrogen. So what is X? The unknown. Can you solve this? So it's so basically oxygen is 0.128 grams, right? So then he's asking to find the moles of oxygen atom. So it's 0.128 grams divided by 16. And that gives you what?
0.008.
So if you use the ratio, it's going to be, according to the ratio, it's going to be 1, like 1 to 1. Hydrogen is 0.016, carbon is 0.08 moles. So the ratio of the atoms is carbon, hydrogen, and oxygen. It's coming out to be 1:2:1. So that's what he's asking for over here. Okay, is this clear?
Yes.
So then the next, okay, so the question was very simple, but they had asked for a lot of things which weren't even needed in the first place. Um, so we had to solve. ये clear है सारों को? हिबा रेदा, Abba, is this clear? So next part is about PV0 NRT. So you're seeing when a 0.148 gram sample of A was vaporized at 60, the vapor occupied a volume of 67.7 cm3 at a pressure of 101. So you have to find the MR of A. So P is given, the pressure has to be in pascals, so it's going to be 101,000. The volume should be in meter cube, so it's going to be 67.7, and it's going to be 10 power minus 6. If you want to convert that into meter cube, divide 2 times by 1000. And N is the number of moles, so moles is 0.148 grams mass divided by MR. R is given in the data booklet as 8.31. The temperature should be in Kelvin, so it's going to be 273 plus 60. So I think it's going to be 333. Whenever you use, the pressure should be in pascals, this should be in meter cube. Try and solve this and tell me what the answer is.
Nine.
Hmm?
9.9.
That's, just 1 minute, Azan. चलो ठीक है. What was the MR? ये उस क्वेश्चन खत्म करें.
9.
कितना?
9.9.
9.9? But that can't be.
Sir, 59.9.
अच्छा, so it's probably 60. ठीक है. अच्छा, now he's asking to calculate the. हमने we figured out that the empirical formula was C1H2O1, right? Which is basically what? 1 carbon 12 plus. So this is basically 30. The MR is coming out to be 60. So that means the molecular formula is going to be double this. It's going to be C2H4O2. The ratio is going to be double this. I mean, the ratio would be the same. The number of atoms would be twice. So this is your molecular formula. Okay? Hopefully everyone knows how to find the molecular formula from the empirical formula, given that you're given the MR. And the last part is compound A is a liquid which does not react with 2,4-D pH or with aqueous bromine. So just two structural formulas for A. So not with aqueous bromine, that means it's not an alkene. And not with 2,4-D pH, that means it's not carbonyl, not aldehyde or ketone. So you're not supposed to draw an aldehyde, you're not supposed to draw a ketone, you're not supposed to draw an alkene. So C2H4O2, one thing is I think you can draw a carboxylic acid. So that's 4 hydrogens. That's one. What's the other possibility? That's not an aldehyde and not a. The other one is an
Alcohol.
Neil, again, how would you make an alcohol?
Uh, C2 with
So if you make two
2O.
alcohol, एक second, if you make two OH groups, right? तो problem है कि H ज़्यादा हो गए, so you can't make an alcohol. Now to get rid of the H, you would have to introduce a double bond. If you introduce a double bond, I mean, you can't make an alkene, so that's not a possibility as well. The only possibility is that you can make an ester. The carboxylic acid and esters are isomers of each other. So you can convert that into an ester. That's the other version. Is this clear?
Yes, sir.
चलो ठीक है. चलो, let's continue with this. ठीक है, next class then.
Sir, are you aware of the fact that वो CIE they've announced that every individual candidate can opt to exempt the practicals as well?
हाँ.
So उसमें what should we do? मतलब should we exempt it or should we go for it?
मतलब अगर मैं होता कोई वो उस pros and cons है तो नहीं वैसे इतने वो, लेकिन if it were up to me, I'll probably lighten my load and not take the practicals. अगर तो कोई फर्क भी नहीं पड़ा ना.
नहीं, लेकिन वो कह रहे कि they will then give you the expected grade of practicals based on somebody else's वो.
नहीं, they'll give you. उन्होंने कहा है कि they'll give you कि आपकी जो बाकी में स्टैंडिंग है ना, मतलब फॉर एग्जांपल आप परसेंटाइल के ऊपर ना, लेट्स से you're 100 में से you're the 80th candidate, right? P1 और P2 में. तो प्रैक्टिकल के अंदर जिसका 80th नंबर पे आए हुए ना मार्क्स,
Exactly, हाँ.
उसके मार्क्स आपको मिलेंगे ना. तो बेसिकली इट्स द सेम थिंग ना कि आपको एवरेज ही लगेगी ना परसेंटाइल वाइज.
लेकिन क्या पता अगर वो उस बंदे ने प्रैक्टिकल्स में सी लियो, then we will also get a C.
किस तरह? अच्छा,
मतलब हाँ.
परसेंटाइल पे होता है ना ग्रेडिंग, तो वो परसेंटाइल पे तो आप वहीं खड़े होगे ना ग्रेड वाइज.
अच्छा, तो मतलब it won't affect our मतलब फिर grade अगर if we're standing on मतलब we're scoring a A and A in our practical in our
नहीं,
theory
अब
and
इससे
MCQs.
बहुत सारे प्रोज एंड कॉन्स है ना कि if हो सकता है कि P1 P2 बुरे हो जाए और P3, अच्छा P3 का जो होता है ना, that's more kind of P3 के, इसलिए मैं कह रहा हूँ एग्जाम्ड, मेरा टिल्ट एग्जाम्ड की तरफ ज्यादा है कि P3 is more kind of a lot of things can go wrong in P3. like P1 and P2 में तो आपकी तैयारी अच्छी है ना, you can still get decent marks, right? But in P3, even if you are 100%, and on that day, on the practical day, a lot of things can be messed around. But and sometimes the mistake isn't even yours. कि chemicals ही शायद इस तरह के दिए हुए हैं, या आपसे पिछला जो कैंडिडेट है ना उसने जाके he added something in your solution. क्योंकि होता ही है कि वो बैचेस में होता है ना, तो इट्स पिछला जो बैच करके गया होता है ना, सारे सॉल्यूशंस चेंज नहीं होते, तो things could go wrong, even randomly go wrong. Like you're trying to टाइम कम है और आप ना, अच्छा प्रैक्टिकल में सबसे ज्यादा गलती क्या होती है, वही होती है कि if you're trying to make a solution, you're doing titration, ठीक है, so it takes a very long time to make a solution, to set up the apparatus, then you do the titration, then you clean the apparatus, then do the titration again, and on the third titration you figure out that you had missed one step, एक चीज ऐड करनी थी वो आपने पढ़ी नहीं है वहां पे. Now you have lost a lot of time, and now you're going to try and do everything again very quickly. लैब वालों से आप मांगोगे केमिकल, दोबारा मांगोगे कि खत्म हो गया, तो वो अपना टाइम लेंगे, तो और आपका पूरा प्रैक्टिकल ना, जस्ट फॉर वन टाइनी रैंडम एरर दैट यू मेड, एवरीथिंग वुड गेट मेस्ड अप. समझ आई बात?
जी सर.
तो प्रैक्टिकल्स के अंदर ना वो जो अननोन फैक्टर है ना, वो बहुत ज्यादा होता है, कि हो सकता है बहुत अच्छा हो, ठीक है, लेकिन चांसेस होते हैं कि a lot of things can go wrong. अब वो डिपेंड करता है लोड के ऊपर, क्योंकि एएस है, एएस के अंदर ना आई वुड प्रेफर कि लोड कम हो तो बेहतर है, कि अगर आप दो पेपर्स अच्छे तरीके से फोकस कर लो ना, बिकॉज एवरीथिंग इज टू मच ए लेवल्स के अंदर ना, तो अगर ऑप्शन मिल रहा है कम करने, अगर ओ लेवल्स होता मैं कहता कि करो एटीपी करो या जो भी है, बट ए लेवल से आपका लोड पहले ही बहुत ज्यादा है, 3 सब्जेक्ट्स हैं और हर सब्जेक्ट इतना ज्यादा है, तो अगर मिल रही है एग्जाम्शन, ले लो एग्जाम्शन. ठीक है, क्लियर है?
जी सही है, ठीक है सर, थैंक यू.
बाकी अपना डिसीजन है, ठीक है, चले, ओके.
जय मां.
अल्लाह हाफिज.